I wasn't expecting so many people, so I'm a bit nervous. So I'm going to just talk for a few seconds so that my voice stops shaking. I prepared a slide to tell you a little bit about me so that I can work out my nerves with you. So my name is Lori King. I am a software developer, and I can't move if I do this. So I started out my professional career as a journalist because that's what I wanted to do to change the world. And then I realized that there wasn't really much changing the world in journalism, so I switched my career to sociology and started a doctorate program in sociology. Left that and got a job as a researcher at a nonprofit that helped victims of violence. And the outcome of that is that I realized I needed to learn Spanish, so I came to Spain to learn Spanish in 2006. I'm not a slow learner. I met my spouse here, and then I stayed. And a couple of really exciting things happened. I started teaching, because that's what Americans do in Spain when we can't speak the language, so our skills don't matter. And then and in there I started volunteering and attended a program called Code Bar, which is it helps people learn how to program, learn how to code. And I wanted to learn to code because I was planning on going back to the States and going back to research, and I thought, if I know Python, then I could do some analysis that we were doing before with programs like SPSS and Stata. Just trying to remind myself to breathe. Okay. And then I heard about this program called Rails Girls Summer of Code, which I don't know if you've heard about. It doesn't exist anymore. What it did was take underrepresented groups and paired you with, created a pair, and you'd spend 3 months working at an open source project with some coaches, and this is where I met Alvaro. He was one of the first people, and at that time I didn't know, I thought a stand-up has to do with comedy, and retro was a style, but I learned a lot. ThoughtWorks was my host company, and after that I entered ThoughtWorks as a graduate developer, and that was about 5.5 years ago. My last project at ThoughtWorks, my last technical project ended in January. I was a data engineer. We were working at a large pharmaceutical, building data products in the data mesh framework, and that's when I started to think about multi-cloud, because they had multiple clouds providers, and this February I started in a new role for a year to assist with people upskilling in infrastructure within the company. So that's how I got here. Still a little nervous, but I'm going to work through this. Okay. So I wanted us to begin with this issue of why multi-cloud, right? Because, and we've all been hearing this, we've been hearing hybrid cloud, multi-cloud, so I wanted to bring up a couple of things of, why some companies are moving towards multi-cloud. So obviously, if you have, most of you have probably heard about that little outage at Google. One of the companies, they accidentally deleted an entire account worth $400 billion. So multi-cloud can help with things like high availability, right? Obviously, we want continuous uptime for our users. So the idea is if you distribute your workload among different cloud service providers, it's going to increase your high availability and your resiliency. So if you have an outage in one, it could fail over into another, or it can help with your disaster recovery options. So you can store your entire workload in either do active-active, which would be really expensive, or active-passive. So in the event that there was a problem in one cloud provider, you can just redirect everything to a secondary cloud provider, or that kind of stuff. Another research is for workload optimization. Some clouds are known for certain features, like people think of machine learning. They might think of Google Cloud being the stronger platform, or maybe other people might think it's AWS. You could have you can have the workloads that need higher compute power based on whichever cloud provider at that moment you've determined to have the best cost ratio to performance and the power potential, right? Okay, another reason is some companies have their workload, have the entire company built around a particular company. For example, you have a lot of Fortune 500 companies that are using Microsoft for their identity management and their workloads for, they use the products. So it's natural that they would continue in Azure, but they may also have some of their other work coming together in a different cloud provider. In addition, another reason can be geographic distribution. So not all cloud providers have multiple availability zones in a given country, and having two clouds can, having your workload on two clouds can help you with issues like latency and storage, or there could be some kind of regulations regarding, which will bring us to governance. There might be some kind of regulations that you need your data to be stored in a particular country, and if you're using one cloud provider, if it doesn't have a presence in that country, you might have to have a workload in an additional country. There can also be issues with, like, the service level agreements will vary over the cloud service providers, and maybe for one country you need it to be higher than it is available in another, or they have different compliance certificates. When we think of the cloud, we tend to think of like GCP, Azure, and AWS, but there are actually multiple private clouds that don't always have the same kind of compliance certificates that we've come to expect of the big three. Okay, so any questions or comments or thoughts? Okay. So I thought we would go over a couple of common multi-cloud patterns that we can see. The first one is just arbitrary. There's no plan. There's workloads in multiple clouds. I've seen this in companies where one company might be. I was working at this startup when I was at ThoughtWorks. At ThoughtWorks, I was working for a company that was an AWS shop, and it was purchased by another company, a larger company that was more into GCP. So this is a scenario where there was just arbitrary. It was just arbitrary. There was no particular rhyme or reason. There was no strategy. They had no governance over their multiple clouds. And the biggest issue for them when they were trying to merge these kind of workloads was the traffic costs. So if you have just an arbitrary thing, workloads here, workloads there, you're going to have a lot of traffic costs as you're moving your data from one provider. So if you have like a website in one and you're storing your data in another, that can lead to a really high cost. Another one is parallel. Parallel is like you have a single application that is split over multiple clouds. It's generally to ensure high availability. It's the same app over multiple clouds. One of the problems with parallel structure is really difficult to use. It can be difficult to use the managed service of a given cloud provider because they are, a lot of them are well integrated into that system, and so it might be harder to actually use. Like, imagine you're using S3 in AWS, and then you're trying to split a workload that's coming from Azure to have data stored into that. No, S3 is not a managed service, so that's a bad example, sorry. And finally, you have the issue of strategic, right? The strategic is when a company decides to make actually plan to engage with multiple clouds, and so they will be caring for, they may decide to avoid vendor lock-in. They're going to have a multi-cloud strategy, so they'll take the strength of a given cloud service provider, and whatever workloads will work for that cloud provider. You can also do this as a plan of disaster recovery. You can create, in this kind of company, like one of the last companies that one of the last clients that I was working at, they had a multi-cloud strategy, and they had a governance team that would cover what type of workloads would go into which cloud provider. Again, some of the drawbacks of that is you can have high traffic costs. Let's say, and also clouds change, cloud providers change. So what might be really good might be a better service today in one of the cloud service provider. 6 months or a year, they can have the same service, the same offerings, the same availability. We see this every year with Summit, AWS Summit. They're bringing out new products that are matching what's in Azure or in GCP. Another challenge of this one is the issue of data consistency, because if you are storing your data in one of the cloud service providers and storing the same data in another one, maintaining data consistency. It might be okay if you have eventual consistency, that is, you're replicating the data into in the secondary place, but if you're in, like, if if you're in a highly regulated industry like banking, you kind of you want your transactions to be identical. I shouldn't be able, if I hit an endpoint in one cloud service provider and withdraw half my money, I shouldn't be able to, by luck, go into another one and be able to withdraw the same amount of money, right? With strategic, you can use things such as the service catalogs. I know that they have equivalent one in Azure and in AWS, and these allow you to have more governance, so you can build security into whatever products that people are building. So basically, you create like templates that people would have to use that can have the security requirements built into whatever service they're using. So I mentioned briefly some of the issues, some of the challenges of multi-cloud. One of those is networking, because networking is one of the biggest challenges, even if you're in one cloud. But when you have to cross between multiple clouds, that intercommunication can be more of a challenge, right? And it could be something as simple like the security group rules. AWS is you can allow things. They only allow rules, whereas if you go into Azure, you can have allow and deny, so you can be getting a timeout error, and you don't even know what's the source of it, or even which of the cloud providers is causing this. So that's a challenge. A second one is security. The more clouds you use, the more you're going to have to manage the security in the applications, and this stuff is well integrated within each cloud provider. You have your the different templates and different permissions for each of the cloud providers, but once you add 2 or more cloud providers, it's going to make it even more complex, and it's difficult to to manage these things together. Another issue is cost. The cloud can be costly, and we've been told since the beginning of time when we started entering the cloud that it's a way to move your costs from on-prem. Like, you don't have to provision a million servers, because you can just scale up and down automatically as you need to in the cloud, right? But these kind of costs can sneak up on you with multi-cloud, because you have to manage a lot more costs and a lot of things. And one of the biggest challenges is data transfer costs, right? As you're moving from one to another, if you're moving across regions, and understanding these policies, the cost optimization policies in a given cloud is really difficult. And at a second cloud, it gets even more of a challenge. Let me drink some water. My voice is out. Sorry. And then finally, I want to talk a little bit about the skill set gap, because it's not enough to just have someone who's an expert in AWS, and then you would need someone to be an expert in multiple clouds, and then therefore they would also need to be, how do these things interact? So that is a major challenge that we can't ignore when we're thinking about going multi-cloud. So we know why people why we could have multi-cloud, and we talked a little bit about some of the challenges of multi-cloud, but I'm going to pause here for a second to give you time to think about it. Anyone here working in the multi-cloud environment? Yeah? 1, 2, okay. Which clouds are you working with? Okay. And there was someone else? Say, do you work together? Okay, that's right. Okay. And do you find it challenging? How Kubernetes can help. Thank you. I did not pay him to be here to support that. Okay. Okay. So we're going to go over some of the issues, right? Abstraction. Was there a question? I thought. No. Yeah. Oh no, sorry. Okay. No, it's fine. Sorry. So Kubernetes acts as an abstraction layer between the application and the underlying infrastructure. This is the advantage of it, right? You can deploy and manage your application, and you're handling this with a bunch of YAML files, right? The deployments, the YAML, the replications, the scaling up, all of this can happen basically in code or YAML files. Regardless of the cloud provider, the YAML file is going to be essentially the same. You need to master YAML, and you're going to be using that if you're with AWS, Azure, or even some of the other cloud providers, right? Kubernetes is an open source platform. It is vendor neutral. So if I'm going to build it on a VM, or if I'm going to build it with one of the managed service, it isn't going to really matter. It can be on-prem, not that we would recommend. Well, I have no opinion about it, but it's vendor neutral, open source, and it's flexible. You can use the managed services like EKS or GKE or AKS to deploy Kubernetes. And if you use a managed service, they're going to handle the control plane, so that takes up some of the, so it worked for the developers team. It's portable at the platform level. Like, you're working in containers, and containers are portable, right? So I wrote here easy to move, and I'm not saying it's easy to move, but because you're having all of your dependencies in one thing, you can, and you're managing with Kubernetes, it's easier than if you were using an alternative. Though I've met someone today, they were talking that they build micro VMs, so maybe I'm wrong about that. We'll check. And it also, if you're using Kubernetes, you do not have, you don't have vendor lock-in, because you can be deploying to any of the clouds, and if you just change your mind later, you can move. Another reason, the biggest one, I think, is the growing multi-cloud ecosystem, from things that automate tasks, or so you can focus on the application logic. If you look around the cloud native, the CNCF, there's so many tools that have been growing in the last few years that are designed to work with Kubernetes, and they can be moved. You can use them in any of the different clouds. There's like tools that you can manage, and even ones that I'm going to go over a few in a few minutes, the ones that can help you manage costs, ones that can help with monitoring, and all of these things. In addition, for resource management with Kubernetes, so it helps with standardized cost management, because there are tools like OpenCost or KubeCost that will help you with live cost analysis in real time or near real time management of your costs to see what you're spending. So then if your costs are going above, then you can work on trying to identify what's the major costs. And we know that it's scalable. Kubernetes is scalable. You scale up and scale down with just a change in the number of replicas. And you can also have that built into your CI/CD pipeline. So looking at a couple of the tools, you have the Rancher Kubernetes engine, which allows, it's multi-cloud, and you can have this to manage across your clusters simultaneously in different platform. It's it can be lightweight with K3. There's Kasten K10. I haven't actually used this, but it's one of the tools that was recommended to me by a colleague in terms of lifecycle management, data management, as well as security. In addition, for networking and service mesh, you have Project Calico. I don't know if you have time, but you should go downstairs. They are here, and you can talk to them about this to help with networking, or Istio if you want to create some kind of service mesh that can help with finding, if you're using a microservice architecture, a service mesh will help you with discovery and traffic management. And then we'll talk a little bit about GitOps. There was a talk on Argo CD. I don't know if you had a chance to see it earlier today. So you have Flux, which you can use to manage deployments, as well as Argo CD as another tool that you can use. Both of these came out of, if I believe, they are CNCF graduate projects. So open source tools that can help with to work with Kubernetes to support configuration management and deployment. So let's say we wanted to go to, so right now we're just talking in the theory, right? So, but the idea is that you could have a multi-cloud Kubernetes deployment of any type of application that that needs to be highly available and resilient. But going into prod, we're going to have to follow some other things, which aren't that different from general. How do we create applications that are reliable, resilient, and highly available? and cost efficient, because we have to think about costs as developers, even though that's not something that it isn't something we talk about that much. So FinOps, right? If you're going to go, we're going to need to talk about what are the pricing models, not just of each cloud, but the cloud combined. And this is the total cost of operations, right? So it's not just about, like, this service might be cheaper today, but it's also, like, we need to track it to see if it's cheap in this moment when we have a contract with this particular vendor. Would it also be cheap if we looked at if it would also be cost effective to to have multiple clouds? And so consistently monitoring the cost to know what the cost, what we're spending, as well as if there's a way to get additional contract and negotiating with a different cloud service provider. Monitoring and observability, a holistic view of the entire project that you're working on, not just within a cloud provider, but across the different cloud providers. This can be one of the biggest challenges because, again, if you're communicating with different cloud providers, their native tools for that provider might not be as efficient, and there may be some delay. So you need to have tools in place, for example, Prometheus, Grafana, that you can see what's going on and that you can trace. If you're, if you want making an API call to a database, you can trace it to see where if there's an error, if you're getting a timeout error, to be able to identify the point at which it's failing, so you can resolve it in that moment and wherever it is. To know what's going on. In addition, it would be good to have in your teams a run book, for example, because it's one thing to know if there's an alarm going off, and we've all had this experience, an alarm is going off. If we don't know how to identify, how to dig into the problem and then resolve it, then we just know something's broken. So it's important for teams to create run books so they can, anyone who's on call or anyone who's in that moment and having an alarm go off should be able to identify the problem and work towards fixing it. Security. Now, security it's one of the biggest challenges, one of the big challenges with a multi-cloud environment, because, like I said, when you are in one cloud, it has a set of best practices, and they might have their own identity and access management, but there's a really design in general to work well within their services that they have in their given cloud, and then it can get a increased complexity if you're adding an additional cloud provider, which might have slightly different structure and monitors because I don't really know if, like, guard duty can be used with something, or what's the equivalent in any of the different cloud providers. So you need to be aware of that and mindful of it, and try to develop something to help you identify any suspicious API calls or any kind of things that are happening within the application. Disaster recovery. This is like a two-parter, right? So it's not just having disaster recovery as I can fail over into a different cloud, but it's also like, what if that cloud fails? It's like within the cloud or between the cloud, to having, to identifying what are your numbers, like how much, the RPO, RTO, you still have to manage that, even if you do have, two clouds. You have the idea that if this cloud fails, I will go to this one, because the time it takes is not just to, how much time do you need to bring up the database again? Are you going to have active, and that could be cost prohibitive? Or are you going to active, passive, but still you have to look at the recovery time point. What's acceptable for your organization? Network connectivity. Now, I will tell you this, to me, networking even within a single cloud is really difficult, is really challenging, and if we're going across clouds, I was trying to create this project to demonstrate for you, and it just kept getting timeouts, because in part my expertise in networking just isn't there yet. And so I would say that this is something that if a team is doing this multi-cloud thing, you need to make sure that you have this particular skill set really deeply embedded in the team. And decide, like, the questions that you have to ask yourself: is it safe to communicate across the public internet? Like, what's the quality? Does the data need to move within some kind of network, like, a VPC tunnel between the two different clouds, to make sure that it doesn't actually cross the public internet, and ensure that you have the proper encryptions and everything like that in place. Management complexity. So this isn't a technical aspect of it. This is it's a business aspect of it, right? So you need the proper governance that you're going to have. How do you manage the complexity of building into clouds? It isn't simply that working in one project, in one cloud, the cognitive load tends to be really high. And if you add an additional cloud, it's going to be even higher. One of the ways you can resolve this is make sure you set up a proper governance, that you have rules of what goes into what cloud, who's responsible for what, and have people behind it. I'm not saying that we need to introduce another level of management, but maybe each project should have a project manager, and that you can help to have a consistency of what is the plan if you're going to be multi-cloud. And building your team, because if you are going to have a multi-cloud strategy, if you are part of an organization that decides that you want to be multi-cloud, you need to ensure that you have a team that has the skill sets and the capabilities to do this. And that means identifying people who are good in, like, have deep knowledge of this kind of things and deep interest in, and provide continuous training so that everyone can learn and grow and be efficient in the work they're doing. So to summarize, designing your multi-cloud would include understanding the workloads, which should go in which cloud, what is the flow of data throughout the life cycle of it. Do you have a stateful or a stateless web application, so whether or not you need to manage state in your clusters, and having a uniform criteria across the organization. So I mentioned before, building out your team, identifying how do you implement IAM. I would say that I think probably everyone here uses infrastructure as code, so finding something that can automatically build out your infrastructure as well as deploy, and being aware of FinOps and the costs, and ensuring that you have monitoring and observability. And this includes runbooks and training, so anyone on the team, if something breaks, they'll be able to identify and troubleshoot. So best practices, or recommended practices, right? Disaster recovery and failover strategy, no matter if you one cloud, two clouds, or some variation of that. Automating your deployment and scaling, monitoring and logging across your clouds, and invest in your people, and practice, like game days to practice for security incidents, security champions that can advocate for the best practices and threat modeling and everything of that sort. And thank you. Are there any questions? I know I talked really fast and I don't even know of what I said. Sorry. Are you just waiting to go out for the networking? Sí, puedes. No sé si puedo responder en español, pero puedo probar.
¿Cuál ha sido tu mayor challenge implementando multicloud?
Pues la failure, no, porque it's the conocimientos. Estoy muy bien con AWS, pero con Azure no tengo tanto facilidades, no capacidades. Entonces, cuando estaba intentando construir uno con un service mesh, estaba teniendo problemas en Azure, sobre todo con el timeouts de seguridad, creo que es algo así. So, I think knowledge. She asked me what was my biggest challenge in multi-cloud. It's like what I was working on before, because I wanted to produce a demo. It's just the lack of knowledge, because I was fine with, I have a strong knowledge of AWS and Kubernetes, but in the moment I was trying to deploy something across the clouds with Azure, I just didn't have the knowledge. So I was getting a lot of timeout errors, and I wasn't able to figure out where that was falling.
Any more questions?
And the takeaway is, do you do multi-cloud? Well, yes, if you have the billions of euros that you need to invest in it. But if not, if you don't need to, no. But if you do it with Kubernetes.
And how do you implement multi-cloud capability on the application level? For example, you have an application that needs like an SNS queue or something like that, something that is vendor locked. How do you manage the abstraction in between? Because you can have your platform and your infrastructure multi-cloud, but the application also needs to be multi-cloud if you use any managed solution, for example.
Well, yeah, I think it's a bigger challenge if you're using a managed solution, right? Because then you have the particulars in the given cloud. I mean, you probably have more experience with this. What would you do? How would you handle it?
I think, well, we saw this morning talk about Dapper, and that is something that provides this kind of sections. You have like a sidecar proxy that it's within your application, and you are like meeting a standard request like to a pub sub, to a database, and this implements the abstraction. So you have a topic in Amazon and a topic in Google Cloud with its own implementation. Mm-hmm. And for example, Dapper is one solution that abstracts this. So you need to talk localhost with Dapper with a standard API, and Dapper will translate to the current provider that you need. That's an example of how to implement.
Oh, that's good. Oh, thanks for the tip. Everyone hear that? Awesome. Cool, thanks. Nothing else?
So you mentioned Kubernetes portability. So if I cannot use Kubernetes, what do I have to do, to I don't know, my platform, so that it can be just as portable?
So you mean you don't want to use Kubernetes to manage your containers? Would you?
Let's say like I work at I don't know, the container level, or I deploy to a virtual machine. What do I have to add to have like that consistent recipe across cloud?
Well, I would. In which way do you mean about consistency? Like, you mean like should you?
Or like have the same capabilities, like networking, or like I don't know. Yeah.
For networking, I would use one of the. I mean, you could do like Cilium or some kind of open source tool to manage your networking. If I'm understanding your question, which is possible that I'm not, because I think I used all my brain cells before.
You will use like you will need to use like third-party products or something.
Yeah, something like that, probably. Yeah, because like I said, networking is my weakest point. I'm trying to build the skills in that, but it's like magic.
More questions? Okay, I think we can wrap it up.
Thank you.
Thank you very much.